Let's take a look at a number of quadratic functions and how their graphs vary. First of all, I want you to take a look at one of the most simple quadratic functions, y equals x squared. And I'm going to write y equals x squared in vertex form. So you'll notice that this is vertex form. If you recall, vertex form is some number a times x minus h squared plus k. So in this case, our h is 0 and our k is 0, and that gives us a vertex at 0, 0. Now, this is exactly the same as y equals x squared. X minus 0 squared is x squared plus 0. Now let's take a look and see what happens as we change some of these things. First thing I'm going to do is I'm going to change the h, and you'll notice that y equals x squared is a blue line, and it's not seen right now. We have sort of an orange line that's on top of it, and I'm going to go ahead and change the h from 0 to 1. When I do, you'll notice y equals x squared, the blue line, stays with the vertex at 0, 0. But notice that the entire orange line, or reddish line, moves to the right 1 square, and the entire thing does, but certainly the vertex does. Next, I'm going to change the h to 2, and then change the h to 3. And you'll notice that as I increase the value of h, the graph of the quadratic moves to the right. I'm going to go ahead and put that back to 0 so that the two parabolas overlap. And let's go ahead and try changing the values of k. So I'm going to go ahead and try 1, then 2, then 3, then 4, then 5. And notice how this red line changes, how the red parabola changes compared to the blue parabola. The shapes remain the same, but the parabola is lifted vertically. Let's go back and put that to 0, and we'll go back to the h and we'll try doing some pluses. So plus 1. Notice that the red parabola has shifted to the left, plus 2, plus 3, plus 4. Notice how we've now shifted 4 to the left. I'm going to go back and put that to 0, minus 0, and we'll go ahead and we'll make this k into minus 1. And you'll notice that the parabola, the red parabola, has shifted down by 1, minus 2, minus 3, minus 4, minus 5. Now, to some degree it looks like the parabola might be getting a little bit wider, but it's not. It's an optical illusion. It's just moving downward. We're not changing the shape at all. Now, I'm going to go ahead and put the k back to 0. And let's take a look and see what is required in order to change the shape of the parabola. Out here in front we have a 1, and you can see that that's true because we still cannot see the blue parabola underneath. Let's go ahead and change that a value from 1 to 2. In other words, a will be larger, and then we'll make it larger again. A is now 3. Notice how notice what's happening with the red parabola. I'm going to make it 4, and then I'm going to make it 5, and then I'm going to go ahead and make it 1 again. Now let's go ahead and I'm going to try something interesting here. I'm going to make it 1 divided by 2, also known as 1/2, and look what happens to the red parabola. I'm now going to make it 1 divided by 3, which is a is now 1/3, and now I'm going to make it 1/4 and 1/5. You'll notice that as I do, something happens to the red parabola compared to the blue parabola. Now, just for the heck of it, let's go back and let's try making the numbers, the a's values, negative. So what if I make it -1? Well, take a look at the red parabola. Look what happens. We get a frowny face. Should not be a big surprise there. I'm going to go ahead and make it -2, and then -3, and then -4, and then -5. And you can see that we just have an upside down parabola that's gotten skinnier. And again, we can try -1 divided by 2, -1 divided by 3, -1 divided by 4. Now these things that you're observing are things that you should be making note of, and I'll try to help you out here. What we're seeing is if I make the h value, if I make this value a large number like with a minus sign in front, then what happens is as this number gets bigger, we move to the right. We move to the right more. As this number gets, if this is a plus in front, as this number gets bigger, we move to the left more. Over here, the k value, what happens is as the number gets bigger with a plus, we move up. And by the way, one thing that I find to be helpful is that I sort of think of the K as a kangaroo because it goes up and down, and the H is sort of like a hippo because it's wide from side to side. So that sort of helps me remember what's going on. And one thing that I want to point out is that although h and k moves the parabola from right to the right and to the left, k moves the parabola up and down, a changes the shape of the parabola. So again, if we have 1 divided by 2, we get a wider parabola. If we have 2 or 3 or 4, we get a skinnier parabola. And so the A changes the shape, and it's going to be kind of up to you to figure out, to play around with this. By the way, I want to point out I'm using Desmos, which is an online graphing calculator, and it's absolutely fabulous for this purpose. So I strongly recommend that you try using Desmos yourself. One of the problems that comes up when dealing with graphing quadratics using Vertex Form is trying to determine how how the graph of one quadratic changes into the graph of another quadratic. So for example, my blue line here is 3 times x minus 2 squared plus 5. Take a look at the blue parabola. And over here, my red line is 3 times x plus 4 squared minus 3. If we had to describe the change from the blue to the red, we would say that the shape does not change at all because the A value is the same. However, we would say, since we're going from the blue to the red, we would say that we have to move, and we can either start going up or down or left or right. We'll say we would have to go down 1, 2, 3, 4, 5, 6, 7, 8 squares, and then we would say we have to go to the left 1, 2, 3, 4, 5, 6. So down 8, left 6 would be how we describe the transformation from the blue to the red parabola via these two equations. If I had to describe the transformation from the blue parabola to the red parabola in this example, you can see that the vertex is in the same place for both examples. However, the A values are different. So take a look. The blue parabola is more narrow and the red parabola is wider. That is by virtue of the fact that the blue parabola has an A value of 1 and the red parabola has an A value of 1/3.